Ah, vale. Okay,
So they can, yeah.
Okay.
The first one?
Coordination.
Hi, I am Gloria Delgado. I'm from the Instituto de Astronomía of the UNAM. This is poster number 3. We all know that chemical abundances are important to study the evolution of galaxies. So now we are using a large grid of photoionization models to study if we can do better with the abundance determinations. Christoph is going to tell you more this afternoon about the grid of models. But in the poster you can see a preliminary analysis of the abundances of nitrogen, neon, and sulfur. We use this grid to explore how well or bad are the ionization correction factors working, the ones that are usually adopted in the literature. So please come and see the poster if you have any questions or if you want to see our results. Thank you.
Hi everybody, my name is Carlos Lopez. As Chris said before, outflows can be driven by star formation. And in my poster, I present a galaxy from the Khalifa sample that has outflow produced by star formation in the center of the nucleus. Okay, thank you. Okay, and we can see here the line ratio map in the N2 and S2 ratios of the range alpha. We also determined from mapping the best model for the shot that is type this alpha region. Our best model describes the alpha. As we can see here as a velocity shock decreasing toward the cone and an electron density decreasing toward the cone axis. If you are interested, it's posted my poster is number 7. Thank you.
Hello, my name is Sebastian Santos. I work with the Institute of Astronomy and you see nothing. Can you laugh just one? So this is just a poster advertising the data release of Khalifa, and unless the resolution gets better, you can see nothing. So, okay. And this is the star formation main sequence versus the stellar mass, and as you can see in the continuous emission, there is a clear distinction between the blue, the star forming galaxies, and the red. Once you go down or large. Then we have different properties, like the stellar velocity mass and the gas velocity mass. This you have seen thousands of times, please don't move it. Thousands of times in the scene survey, for example, and the low racing. And I didn't know that somebody was using exactly the same points. I apologize. We will totally discover it. We can make it in a different way. But this one is, I think, is totally new because we saw here the rotators in the entire sequence that was not seen by scene, and I think that it was exactly the same that some people want to highlight because we are working on the same things. So if you want to hear more or read more, I'm here around somehow. We can talk. And sorry, I have another post. So hello. My name is Sebastian Santos. Obviously, I'm not Alberto Boat. He's much nicer and funnier than me. And this is just an advertisement poster, but Alberto told me to put it here, so I did basically like 5 minutes before taking the plane. There's basically advertising the CO mapping that we are doing on the Khalifa galaxies. And the poster is out there. This is the preliminary results where we show the distribution of CO on top of the galaxies of the Khalifa satellite that we have shared. There is 177 galaxies that has been shared of them. 135 has been shared with 3 second sampling, and these are the velocity maps. If you are more interested about this mapping, that we are continuing also with other tools like ALMA and so on, just ask me, as I told you before, I'm around.
Hi, I'm Loretta Bartolomé from the University of Virginia. I'm working towards my PhD. My advisors are Adam Leroy and Aaron Evans. And in my poster, I'm presenting the first high-resolution, high-sensitivity radio continuum data from a local sample of yoders. And this is important since you've heard Sylvain talking about how compactness is important for star formation AGN connections. And knowing actually the true sizes of these systems, especially for yoders, is very complicated. Not only because you need high resolution, but you also need to observe them in the right wavelength. And this is the radio. Radio it's not obscured by dust, so observing them at radio continuum is especially important. And we found very compact sources with about 100 parsecs in radius. And these, it's especially important if you want to derive things like star formation rate surface densities or gas mass surface densities, which place them in a very extreme regime. So if you want to see more, just talk to me. I'm in PostersC 15. Thanks.
Hi, I'm Igor from Moscow State University. We present the results of our study of triggered star formation in superbubbles of local dwarf irregulars, several dwarf irregulars. We focused on two questions: what triggers star formation there, and how the ongoing star formation influence to the parent H1 superbubbles, kiloparsec-sized superbubbles. We used Fabry-Perot observations and showed that kinematics, structure and kinematics of EMS gas is very perturbed there and may destroy the H1 shells there. Also, we showed that in several galaxies where star formation see on the one side of superbubble, it may be triggered by H1 superbubbles collision. And we can see triggered star formation also on the local scale. So see my poster number 23. Unfortunately, it is losing color, so be hurry to see it until it completely disappears. Thank you.
Hello everyone, I'm Ivan Lucena, postdoc at Católica University in Chile. I would like to invite you to see the PostersC that is located at the back of this room, where we identify a peculiar sample of blue and star-forming isolated elliptical galaxies. We found that these blue star-forming ellipticals were assembled as Ilias classical red and dead elliptical galaxies, but they were rejuvenated by the recent events of cold gas separation. And since these galaxies are very isolated, they can be used to estimate the fraction of gas cooling from the cosmic web, for example. Further work with the integral field spectroscopy on these ellipticals is important because this is a unique sample to study the process that triggers star formation activity in nearby galaxies. Well, thank you.
Good morning, everybody. I'm Claudia Mancuso from Sista Trieste, Italy. And what I'm presenting here is a work that appeared on the archive last Tuesday, so it's a new one. And what we've done was reconstruct in a model-independent way tomographic star formation rate functions out of Z equal 9, and to use them, to plot them against many observables, also via the continuity equation, and to provide some, let's say, predictions, both in counts, number counts, and redshift distributions for the upcoming and actually current facilities, both in the millimeter and radio band, in order to probe the right angle of the star formation rate function at redshift bigger than 3. One last thing, I'm a PhD student in my final year and I'm looking for a postdoc, so if you know about anything that can be related with this work that I actually haven't found yet, please just let me know. Thank you for your attention.
Hi everyone, my name is Joel Roediger. I am a Posted Fellow at NRC Kurtzburg in Victoria, Canada, and my poster presents the deepest analysis to date of the color magnitude relation, which we performed using multiband imaging from the next generation Virgo cluster survey. Our main result is shown in this plot here. We have 10 panels for 10 color magnitude relations. I'll draw your attention to the red line, which represents a non-parametric fit to the data points shown in black. And what's most interesting is that towards low galaxy masses, we see a strong flattening of the red sequence. And the other lines in these panels represent red sequences from galaxy formation models. And in no case do we see that the models reproduce the shape of the observed red sequence. If you'd like to hear more about what ideas we have regarding the models and the flattening, please come see me at Poster 47. Thank you.
I'm Olga Simchenko, and the first author of the poster is my student Irina Proshina. We have studied a small sample of lenticular galaxies with the outer bluish rings, which are also seen in the UV, and indeed paintings of its spectroscopy, and indeed we have found emission lines with the flexification by young stars. We have determined the parameters of the stellar populations near the rings in the stellar disk, and while the stellar populations have a range of ages, we have everywhere a very low metallicity of the stellar populations. But when we have determined the oxygen abundance of the gas in the rings, we have found solar metallicity in a very narrow range.
I'm Becky Smethurst from the Galaxy Zoo team in Oxford, and my poster is on a code I've written called StarPy, which uses Bayesian statistics to infer the probability distribution of the time and exponential quenching rate in a galaxy given its photometry. And what we want to do with that is, once we have that for a single galaxy, is use it across populations and look at the morphological dependence. So we actually use the Galaxy Zoo classifications in a new way. Instead of applying a threshold and splitting only into early types and late types, we use them as a probabilistic weight when we combine these probability distributions. Say for green valley and red sequence, actually find the green valley is not a red herring as previously thought, but is a transitional population for all galaxies. One result I really want to highlight is when you use this method on a population of AGN galaxies, you find that we have rapid recent quenching having occurred, which you don't see in inactive galaxies. And the really cool thing is that maybe you would say this is negative AGN feedback, you'd be really tempted, but actually what we can't answer is, are the AGN the cause of the quenching or the consequence from something else? Poster 51 is the obscenely yellow one over there.
Hello everyone, my name is Kai Zhang, a postdoc in the University of Kentucky. And we are using manga data to explore the diffuse ionized gas in star-forming galaxies. We see that the nitrogen 2 alpha generally drops as a function of radius, and at the fixed radius, the dispersion is large, about 0.2 times. But if we color encode the dots by this H alpha surface brightness, we see a very beautiful rainbow pattern, and the dispersion is significantly reduced at the fixed H alpha surface brightness. This is because the nitrogen 2 of H alpha is significantly enhanced in diffuse ionized gas, and the diffuse ionized gas will dominate the low surface brightness region. We see this rainbow pattern for many different emission lines, and in almost every star-forming galaxies. So the change in line ratios would significantly bias the magneticity measurement and the gradient, especially at the outskirts of galaxies where gradient is claimed to be tragic. So if you want to check out why and
Good morning, I'm Enrica Bellocchi. In my poster I present the result obtained from the 2D kinematic characterization of the ionized gas phase as traced by the H-alpha emission line for a representative sample of local luminous and non-luminous infrared galaxies and observed with BMOS with PLC interactive spectroscopy. I compute the kinematic parameter for the whole sample, and in order to distinguish between rotation and dispersion dominated systems, and we see that most of the galaxies are rotation dominated. In terms of dynamical ratio, they cover the gap in between local spiral and local elliptical galaxies. We also distinguish the galaxies between this convergent system using kinemetry, which is a method that allows to compute the kinematic deviation with respect to the ideal that in this case in the velocity field and velocity dispersion maps. Thus, the relationship between the total kinematic asymmetry as a function of the infrared luminosity, projecting perseveration, and dynamic aberration has been shown. And finally, a Bayesian fitting approach is going to be applied to the Khalifa news data to derive the kinematic component characterization of the local galaxies. Thank you.
Hi, I'm Guillermo from the in Granada. The layout of the poster might be familiar, but it is intended. So in this work, we needed to perform a self-consistent study of blue compact dwarf galaxies, studying metallicity, stellar properties, and gas. But the key point of the study is to compare two tools we use for derive star formation histories, study the galaxy evolution, and then presented in this pilot project where we compare the CND, star formation history from CND and from stellar fitting. So from this work, we thought that we have to go to full 2D, and we observed 6 galaxies with MUSE, and another one, 6 galaxies with PPAC, and all of them have counterpart in HST in at least 3 bands, so we can perform CMD star formation histories and compare with the star formation histories derived from the IFUs. And here has to use some results. And in the next poster I have as well. This is going to be short. So we present results from the oxygen abundances and nitrogen and overall ratios from Khalifa survey. And in here we use the H2 chemistry program by Pérez Montero, where you can get oxygen and overall chemical abundances. And here we derive, for example, the slope, the mean slope from all the galaxies in Khalifa. And here you have the slope, and we don't find any correlation between the oxygen in here and the nitrogen and overall gradients. And here you see what we find in Khalifa for the stellar properties. We find as well characteristic value at the effective radius for the analysis for the gradients. And you see that this dispersion is much lower for this characteristic value, as you see, and as well that the weight range in N overall is wider, so you can get more precise abundances in the N overall. And just to say that we find correlates with stellar mass and no other properties.
Hi everybody, my name is Lisa Mancillas. I'm a PhD student in the Paris Observatory. The title of my poster is The Galaxy Halo Collection, Scaling Relations. And in this work we want to know how the stellar to halo mass ratio, which is presently determined for late-type galaxies, using abundance matching technique, is mapped in the scaling relations such as radio mass, Bulge to mass ratio, and Tully Fisher, and the luminosity to total ratio, to different effective radius. To do that, I generate a mock catalog of a galaxy disk populations using a semi-empirical approach, and where each galaxy is modeled with a statistical model following the moment-wide formalism, but also including the Bush formation and the contraction of the halo. As you can see in the results, we see that this stellar fraction let its print in this correlation. This is a prediction which can be tested with observations of Khalifa and Manga, such as Stefan and Luminova showed in the last talks. My poster is there with 77 if you want to know more. Thank you.
Pues